probability and two-way frequency tables. This is a frequency table. You have the events A, B and C, W and X. Work out row totals and column totals, and then work out a table total. The probability that event A happens, event A is in a column, the total is 20, so it's 20 out of the table total 50. 20 out of 50. The probability that event X happens, and X is in a row, the total of that row is 30, so it's 30 out of 50. The probability that event W and B happens, so W is in that row, B is in this column, so you have W here, you have B here, and where do they meet up? On the 2. So that's W and B. That 2 is common to both W and B. W and B. So that's 2 out of the table total 50. The probability that W happens and not B. So W happening is here, that's all of this, and not B. Now B is in a column, so the other columns which represent B not happening are these. So where do you have W and not B? Which numbers are in W and they're not in B? Okay, the 8 there, it's in the event W and it's not in B. The 10 is in event W but not B. So you add them, 8 plus 10 out of the table total 50. And you can simplify these afterwards. You've got 18 out of 50, you can cancel it down later. The probability that event B does not happen. B is in a column, so the other columns representing the other events are A and C. So the probability that event B does not happen is 20 plus 24 out of 50. The probability that event W happens, or B happens, or they both happen. So W is in a row, that's all of these. B is in a column, that's all of these. So it's everything that's highlighted. Every number that's highlighted either corresponds to event W or event B. Okay, that symbol there is all. So 8 plus 2 plus 10 plus 4 divided by the table total, 50. The probability that event X happens, or A dash, or not A. Well, event X is in a row, event A is in a column. So A dash is all of the other events which are in columns. So these numbers are all to be added together. So for example, that 2, it's in either event X or it's in event A dash. Yeah, so that's all. So 2 plus 10 plus 12 plus 4 plus 14 out of the table total 50. Okay, we move on to conditional probabilities. This vertical line here represents conditional probability. So the event A happening, given that X has already happened. Now with conditional probabilities, start off by looking at this letter, the one on the right hand side. event X, and event X is in that row there. The total for that row is 30, so the probability will be something out of 30. Now you look at event A. Event A is all of this. And where do the two meet up? On the 12 out of 30. The probability that event B happens, given that X has already happened. So again, look at the one on the right hand side, which is the X. Event X is in that row there, and event B is in this column, and where do they meet up? On the 4. 4 out of 30. 4 out of 30. What you can see from these conditional probability questions is that the probability is always out of something which is not the table total. If you look at the previous examples, they were all out of the table total. So that's out of 50, this one's out of 50, this one's out of 50, and so on. But when you move on to conditional probabilities, this number here always refers to the total for that event there. The event, well, the probability that event W happens, given that B has already happened, so let's focus on that B first. There. What's the total for event B? 6, which means this is something out of 6. Now look at event W. There's event W, it's in a row, and where do they meet up? On the 2. The probability that event X happens, given that C has already happened, so let's start off with the one on the right hand side. Here's event C. The total for event C is 24, so we know the probability is something out of 24. Event X is in this row here, and where do these two meet up? On the 14. Again, if we start with event X, the one on the right hand side, so we've got this, so it's something out of 30, that's the total for event X, something out of 30, and then you're looking for the event A dash. A is in a column, so not including this. So if you look at events B and C, they're in columns, so where do the B and C meet up with X? Well, they meet up on the 4 and the 14. The probability that events A and B both happen, okay, so where does A and B, where do they both meet up? Well, event A is in this column, event B is in this column. Where do they meet up? Nowhere. A and B are mutually exclusive. Having one excludes the other, so the probability that A and B both happen is 0, because they are mutually exclusive.